Hi, my name is Shruti Vinod, and this is Lab Report 1 for Physics 2212. So basically, the purpose of this lab was to experimentally measure the excess charge and approximate number of electrons transferred onto a piece of charged clear tape. And I've listed the principles as follows, which is assuming a charged object should be a point charge, understanding and applying Newton's second law, Coulomb's law also, and using approximate dimensions of an atom to calculate the number of deficient electrons per atom on a piece of charged tape. And the overview was to estimate the approximate deficiency of electrons in a piece of tape and to calculate the force on one tape that it exerts onto the other and derive an expression for Q by rearranging Coulomb's law and incorporating Newton's second law. So the main physics ideas involved are Coulomb's law, which explains the relationship between two-point charges by describing the electric force acting between them, and the gravitational force on an object near Earth's surface, which is given by F is equal to mg, and where Newton's second law states that if the net force acting on an object is zero, the object will not accelerate. So here the initial conditions of the system are that is defined by four pieces of initially uncharged clear tape, and the surroundings is that it's on a table. These pieces of tape are on a table with no external electric fields to disrupt the experiment, and we followed the following figures 2, 4, and 5 to understand how to implement this experiment. And basically, the model was that each piece of charge tape was used to model a point charge to make observations of interaction between point charges easier on a macroscopic scale, and we had assumptions where air resistance is negligible, only gravitational electric forces are acting in the y direction. All pieces of tape are point charges, and each U-tape ended with the same charge after the charging process, and charges evenly distributed along tape's length. So basically, the U-tip was positively charged as the pen was induced into a negative charge, as explained in the manual, and it was attracted to the charged U-tip. And in figure 4 down below, when one tape is held near the other with the second tape secured, the top tape appears to float due to the balance of forces. And as explained in the previous slide of our surroundings, the only forces acting on them are gravitational force and electric force. And once the U-tape B reaches equilibrium, it remains stationary, meaning that the force on it is zero. This balance implies that the downward gravitational force equals the upward electric force. So here are all the calculations, and I have written out how I have gotten these calculations also on the piece of paper on the right. As you can see here, this is my glow script model, and we have two balls, and the one in the middle is U-tape B, and the one on the bottom is U-tape A. And the green arrow is the gravitational force, and the orange arrow is electric force on U-tape B by U-tape A. And here in the results, we can see the charge on one piece of tape, number of deficient electrons on one piece of tape, and the atoms per deficient electron on one piece of tape. And these are pretty similar, pretty close to what I manually calculated. So the data and the discrepancies is that there's no real point charge. These are like widths of tapes of charge, and charges on both U tapes are not exactly likely the same. And sources of error are like mismeasurement of the length and width of the tape, or the separation distance and the holding tapes at the different positions, and possible electron transfer to surface of table or anything else. So what if electrons had positive charge and protons had negative charge? What would change about these observations? So the charges on the U-tapes would be negative, not positive instead. And therefore the electric fields produced by the U-tapes would reverse in direction, causing the pen to repel the tape instead of being attracted to it. And the thing that would still be the same though is that the pieces of tape would still repel each other because they have the same charges. And why is it important to handle the charge tapes as little as possible? And because as we saw from putting a hand near the charge tapes, the hand and the tapes were attracted. By touching the tape, it's possible that the electrons travel from our hand to the tape, changing the charge from what it should ideally be. And this would decrease the positive charge, and the same goes to the pen. And the assumption that two tapes have the same charge cannot be 100% upheld, and the value for the number of deficient electrons will change, meaning that the ratio of atoms to deficient electrons will change. Thank you so much.